Hello guys, and welcome back to Jamb chemistry class. So we're having chemistry today, and then today we are going to be looking at covalent bonds, covalent bonding. All right. So in the previous class, we looked at electrovalent or ionic bonding, right? And we said in electrovalent bonding, right, there's usually a transfer of electrons from one atom to the other, right? But in covalent bonding, it is not like that. Electrons are not transferred from one atom to the other. Instead, electrons are shared. Electrons are shared. This is the major word here, shared between the two atoms. Please, before we continue, know that this video tutorial is brought to you by O3Schools Jamb App. It is being currently displayed below the screen. Please, O3Schools Jamb App is all that you need to be successful in your Jamb examination. It has all the recent past questions that you need, right? It has wonderful features that will enable you to study. There's a study mode, there's a practice mode, there's a mock mode, there's an exam mode. You can practice in any of the modes. Apart from that, we also do a weekly Jamb UTME challenge for students that are writing Jamb for the particular year, right? So where you can participate. Apart from winning prizes weekly, you win prizes weekly, and also you can be able to checkmate yourself. So when you take a test or when you participate in the challenge for a week, for example, you see your score. When you see your score, you see your weakness. You see that in English you score 20, right? So in chemistry 70, physics 90, mathematics 15. So you say that my weakness is English and mathematics. I will need to improve on them. So it tells you where to improve on, right? Because you are seeing your score. So that before your exam, you have already done a whole lot of work improving yourself. Do not joke with the app. Activation is just 2,500, and make sure you go to Play Store, download that app, and activate it for your sure success in the exam. All right, so let's go back here again. So we said in covalent bonding, electrons are shared and not transferred between between the two atoms. Now, a pair of electrons, a pair that is two electrons now, that is shared between these two atoms is what constitutes the covalent bond. A pair of electrons that is shared between the atoms usually constitutes the covalent bond. Now, another important thing that you need to know is that are the two elements who are sharing this electron pair, the two elements sharing the electron pair are almost nearly non-metals, right? So the two elements that are sharing this electron pair are always nearly non-metals. They are always nearly non-metals, but there are a few exceptions. That's why I am choosing my word very carefully, right? So the two elements that are sharing this electron pair, right, are nearly always non-metals, but few exceptions do exist. All right, so you must take note of that. Examples of before I would give you examples of covalent bond, know that covalent bonds, covalent compounds are also called molecular compounds. Molecular compounds. Why? They are called molecular compounds because they exist mostly as molecules. They exist mostly as molecules. Examples of molecular compounds are of covalent compounds are what? We have hydrogen, H2, iodine, I2, even Cl2, HCl, NH3, C2, H6, C2, H4, even O2, right? These are all These are all covalent compounds, right? They exist mostly as as molecules, and that is why we can also call them molecular compounds. All right. Now, how do you differentiate that this compound is an ionic compound or electrovalent compound, or it is a covalent compound? How do you differentiate that this element or this atom rather is covalent and it is not ionic? In the previous episode, if you have not watched the episode, please go back and watch it. Now, we talked about electrovalent or ionic compounds, right? Now, how do you tell that a compound is ionic or it is what? It is electrovalent, sorry, or it is covalent, right? So now, differentiating them, we use what we call Fajans rule. Fajans rule. We use Fajans rule to what? To talk about that dichotomy between what? Ionic compounds and what? And covalent what? Compounds. Fajans rule was formulated by a man called Casimir Fajans. Casimir Fajans in the year 1923, right? And he formulated what? This theory that we can use to adequately what? Differentiate between ionic compound and covalent what? Compounds. So if you use this rule, you can be able to tell that this compound is actually ionic or it is what? It is covalent. All right. So now, covalent compounds do usually have what? Some properties, usually have some characteristics that makes them what? Make us know that it is covalent. Right? While some ionic compounds have what? Some special characteristics that make us know that what? That they are what? That they are ionic. So that is what Fajans rule was for telling us. Fajans rule was used to what? Is used to differentiate between ionic and what? And covalent what? Compound. Now, how do you know that a compound is ionic? Using Fajans rule. So Fajans rule, number one, right? Number one, the summary of the whole rule is that one, right? That ionic compounds are favored by a low positive charge, positive charge, right? A low positive charge, a large cation, and a small anion. Right? So now, Fajan rule said that what? That an ionic compound or ionic compounds are favored by a low positive charge. Right? So the positive charge on the what? On the atom has to be low. Right? A large cation, the cation has to be the size of the cation has to be very big, and what? And a small anion. Right? The size of the what? Of the anion has to be what? Small. This is what how to differentiate between what? An ionic compound and a what? And a covalent compound. While he said number two, that covalent compounds, in the other hand, covalent compounds are favored by a high positive charge. High positive charge, right? Then a small cation, and then what? A large anion. Right. So this is just what the summary. Number one, that the ionic compounds are favored by a low positive charge, a large cation, and a small anion. In your exam, you will give you a compound and you may be asked to tell which type of bond exists between or those between in the compound, right? What type of bond exists in the compound? So once you know what how an ionic compound is, right, you'll be able to what use what these properties that have been listed or these characteristics have been listed about the ionic compound to remove what some of the options. All right. So then we give you a question example. Aluminum chloride, for example. Now, I give me aluminum chloride. We are told is aluminum chloride. Which of the following bonds exist in aluminum chloride? A. Ionic bond. B. Covalent bond. C. Dative bond. D. Metallic bond. Right. So once you see something like that, right, with this, you can be able to tell which type of bond exists in such a compound. Right. So this is the summary of Fajans rule. The covalent compounds are favored by a high positive charge, a small cation, and a large anion. Let's see aluminum chloride as an example. Aluminum chloride. All right. So aluminum chloride, right, contains what? A metal, aluminium, and a non-metal, chlorine. Right. Now, in the first episode, what we talked about, in the previous episode, what we talked about ionic compounds, we say what ionic compounds usually have what a metal and a non-metal. So anybody that sees this will be drawn to quickly say, aluminum chloride is what is an ionic what compound. But no, the person is wrong, right? The fact that it has a metal and non-metal together does not completely make it what? Ionic. It is not very ionic, not completely. It is not ionic, right? Why? Because the charge on aluminum is very high, Al3 plus, right? And what? It has a massive what? It has a massive what? Anion. The chloride ion. The size is very, very what? Massive, right? So this is why we cannot say that what aluminum chloride is what? It's ionic. Instead, using Fajans rule here, we'll see that our covalent compound are favored by a high positive charge, which is 3 plus, and then what? A large anion, chloride ion. The size there is that's a very, very big what? A very big chloride ion. So with this now, we see that what aluminum chloride is not actually ionic, right? But it is what? It is covalent. And it's not just covalent, it is dative. It is dative. Dative bond is another type of bond which we are going to discuss in the next class, right? Now, dative bond is a type of what covalent bond. It is called coordinate covalent bond, right? So this compound aluminum chloride is not ionic. It is what? It is covalent, right? So now another thing you should note here is that aluminum chloride, right? It exists as a dimer in solid state. Aluminum chloride exists as a dimer in solid state. That means it has the formula of Al2Cl6 as opposed to what? AlCl3. That is just something to note by the wayside. It exists as a dimer. Aluminum chloride exists as a dimer in the solid state and has what? This formula Al2Cl6, not AlCl3. All right. Okay, now that we have seen Fajans rule, we have known how to differentiate between a ionic compound and a covalent compound. Then we'll move further ahead to see to consider, for example, what the covalent bond between two atoms. How does it happen? How does this sharing of electron, this sharing of paired electrons happen? How does it happen? Now let's quickly see an example. Now we're going to consider the covalent bond between the formation of ammonia between what? Nitrogen and hydrogen, right? The formation of what? Of ammonia is NH3 between what? Nitrogen and what? And hydrogen. But before we do this, let's see generally how what covalent bonding what works, right? So in covalent bonding, you are going to have what? An atom A like this. Let's say having what? Electrons here, 7 electrons, plus another atom B having what? 7 electrons too. Let's see, for example, just to illustrate how it works before we look at that. All right. So we have this. Now this is what? Atom one, right? Which is usually what? A non-metal. A non-metal. This is atom what? Two. Which is usually what? A non-metal or what? Metalloid. All right. Now, something I failed to mention is also okay. I think I've talked about that. I told you that that covalent bond usually what exists. The two elements that form covalent bonds, they are usually nearly what? Always non-metals, right? So it can be between what? Two non-metals or between a non-metal and a metalloid, right? So now let's continue. So we have this. This is what? Atom one. This is what? Atom two. So how does this sharing of what? Of electrons happen? This atom A needs one electron to be stable. Then this atom B needs one electron also to be stable. Now, what do they now do? Since they both need one, right? They can now have a shared pair of electron to become stable. So this is what now happens, right? And I'm going to have what? Let me take this down. I want to have what? This atom A, right? Then atom B will follow like this. Now, this atom B, right? So I'm going to have 2 electrons here, 2 electrons here, 2 electrons here. Then I'm going to have 2 electrons here, 2 electrons here, 2 electrons here. Then this one electron that are here that are not paired, right? We can now pair them here. So you see that right now they now become very stable. they have what the octet what electronic configuration states already. So this is how what electron what pairing what occurs in what in covalent what bonding. This is how the covalent bond is formed, right? A shared pair of what of electrons, just as you have seen what in this illustration. All right. Now that's as simple as that. And if you understand that, now can I look at what the formation of ammonia from nitrogen and hydrogen? Okay. So let's look at the formation of ammonia from nitrogen and hydrogen. All right, so now I've seen that. Now we're going to have how many? There are what? Three what? Nitrogen what atoms there, right? In ammonia, three hydrogen atoms. And nitrogen is the what? Remember, is the seventh element. Nitrogen is the seventh element, having atomic number 7. That means it has what? How many electrons in its atomic shell? It has 5 electrons in its atomic shell, actually, because the first K shell will take 2 electrons. Now, let's say, for example, this is how it will look like. This hydrogen. Let's present what the electron with that. Hydrogen is 3, right? You can see 3 atoms of hydrogen here. All right. So now this is what is combining with nitrogen. Nitrogen in the first shell having 2 electrons, and then in the other shell now, this nitrogen, the other shell having how many electrons? 1, 2, right? I think one more. You can see now it has 5 electrons in its what outermost shell. Now, what will now happen here? If you see very well now, to do this, right, to make this stable, there are what 3 what electrons here. So those 3 electrons will pair with what? With the if you take one from here, let's say put one here, hydrogen will, okay, let's just see how it works here. So what happens here is that what you're not going to have nitrogen, right? Still having 2 electrons in this outermost shell. Then here we are going to what? Take 1 electron from nitrogen and 1 from hydrogen. So we are going to have something like this, right? This is hydrogen electron here, right? Then here also you take 1 and then you take 1 from hydrogen. You get, right? So that is that. Then here also you take 1, then you take 1 from hydrogen. Hydrogen atoms electrons are already completed. There are 3, 1, 2, 3. That is complete. Now, if you see how many are left here, how many we have taken 3 nitrogen, 3 hydrogen. Hydrogen is exhausted. Remaining 2 more what nitrogen what atoms. So what you do, you take what 1, you take 2. Now the 2 what now become here. If you see very well here, you see that what this one is paired. These are paired. This is a paired. This is a what paired electron. This is a paired electron. This is a paired electron. Why this is a what? This is a lone pair. It is not what paired with any what hydrogen. So at this stage right now, the nitrogen is stable. Is completely stable. So, and this is what happens in what in the formation of what of ammonia. The hydrogen atoms what combine with what with nitrogen to what to give what ammonia in this format, and it's a covalent bond because there's a shared pair. These are what shared pairs of electrons, right? Why this is a what? It's a lone pair. Because what a lone pair, right? Even this one is also shared, right? So they are called shared pair of electrons. The ones that are paired, while the other ones are what? This one is called what a lone pair because it is not paired with any hydrogen what atom. Right? So this is just simply what happens in the formation of ammonia. Now, having seen this now, we are going to drive the point home, right, by talking about some of the characteristics of covalent what bonds. Some characteristics of covalent bonds. So let's run through them. One, covalent bonds actually form between what? Between two non-metals, or between what? A non-metal and a metalloid. All right, I think we have stated that. I've stated that severally, right? So usually between what? Two non-metals, or between a non-metal and a metalloid. And know that what that the covalent bond between what? Between two atoms is very, very great. It is very massive, right? So that's another what property or characteristic. Covalent bonds between what? Two atoms are very great. They are very what great. They are not small at all, right? Themselves no small, right? So the covalent bond between two atoms are very, very great. It's very, very what great. right? Now, another thing you need to know is that what the covalent bonds, right? And covalent bonds does not lead to the what? To the formation of new electrons, right? Covalent bond covalent bond now does not lead to the formation of new electrons, right? The bond pairs them, right? So it is the bond that pairs the two atoms together. Covalent bond does not lead to formation of new what electron. No, a new electron does not come from one, does not have to transfer electron to the other, right? It is the bond that pairs them. It is that bond that is covalent. The bond that pairs them is the covalent bond we're talking about, right? Now, number 4, know that what covalent compounds are not soluble in water, right? Covalent compounds are not soluble in water. Just like we saw in the previous episode about ionic compound, we say they are soluble in compounds and they can even be used as electrolytes, right? Also, another thing is that what covalent compounds, most covalent compounds, rather, most covalent compounds are not good conductors of electricity. Conductors of electricity, right? Most covalent compounds are not good conductors of electricity. Know that also. Then I think another one will be that which one am I missing out? So we are seeing these two non-metals or a non-metal and a metalloid. Covalent bonds between two atoms are very great, very, very massive, right? Also, they exhibit relatively low melting and boiling point. Exhibit relatively low melting and boiling point. For example, if you want to check the boiling point of hydrogen, the boiling point of hydrogen is, I think, minus 252.9 degrees Celsius, around 252.9 degrees Celsius, right? Minus, rather. Right? That is the boiling point of what? Of hydrogen. It has a very low boiling point. What about, let's say, ammonia itself that we just looked at? NH3 has what? The boiling point of 33.4 degrees Celsius, right? Then, of course, ethane has a boiling point of please. This is minus. Has boiling point of minus 33.4 degrees Celsius. Ethane has a boiling point of 89 degrees Celsius, and so on and so forth. If you see their boiling point, they are relatively very, very low. They are very, 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 very low. All right. So they have a relatively low melting and boiling point. So these are characteristics of covalent compounds that what you come across. So you just if you know the characteristics of of a ionic compound, we looked at it in the previous episode. If you know them, then this one will be easy peasy for you. Like I said, it is between what they are formed between two non-metals or a non-metal and a metalloid. Covalent bonds between two atoms are very, very great. It's a very, very massive, great covalent bond between them. Now, covalent bonds do not lead to formation of new electrons. Like we said, it is the bond that pairs them, right? Then, covalent compounds are not soluble in water. They are not soluble in water, and most of them are not good conductors of electricity. And then there's a bit relatively low melting and boiling point, right? So we have said that in covalent bonding, electrons are not transferred, but they are what? They are shared, right? So the next type of bond we look at, we're going to look at coordinate covalent bonds, usually called dative bonds. So it's a type of covalent bond, right? But we're going to see the difference in the next class. So do not forget to like this video, give it a like, please. Do not forget to subscribe to this YouTube channel, right? Subscription is free. Just click on the red subscribe button below this video, and of course, you will be getting notifications from us once we release a new video. It is free to subscribe, and do not forget to share this video also to your friends, to your class groups, and to what, to people who you know that this will be beneficial to them, right? And of course, as you do this, see you in the next class. Thanks for watching.